So today we're going to look at probability tree diagrams to be specific. And what we're going to learn to do is construct tree diagrams and use them to find probabilities of two or more independent events. We'll talk a little bit more about what a tree diagram is, what independent events are in a minute, but just a couple of pieces of information and equipment that will be useful today. A calculator, and if you've got them, some highlighters, because it will make things a little bit clearer, and we'll see when we do an example now. So I've got an example question here. I've got 5 cards. 3 of them say yes, and 2 of them say no. And what I'm going to do is I'm going to pick one of the cards at random. I'm going to have a look at it, and then I'm going to put it back. I'm going to mix all the cards up so they're all random again, and I'm going to pick another one at random. And what I want to know is what the probability is of getting 2 yes cards, and then what the probability is of getting 1 yes card and 1 no card. You might look at this and think, well, can't we do a possibility space, a sample space, like we did last lesson? Because you either get yes or no, and then you get yes or no again. And so you can see the different options. But because there are more yes cards than no cards, it means the probabilities are not equal, and we can't do a possibility space, a sample space. We can't do that. So what we'll have to do instead is a tree diagram. So I'll show you how to construct one. The first thing we've got to consider is the 2 things that are happening. And the first one is we're picking a card at random. So the first pick, well, 2 things could happen. It could be a yes, or it could be a no. They're the 2 possible things that could happen. Right, let's have a look and think, well, what's the possible probability that the first pick is a yes? 1, 2, 3 out of 1, 2, 3, 4, 5. 3/5. Because there are 3 yes cards out of 5 cards total. And what's the probability that it's a no? 1, 2 out of 5 cards total. So that's what can happen on my first pick. And then I've got my second pick. Now, the way a tree diagram works is it almost creates sort of different timelines of different things that can happen, and you carry them on in all sort of directions. So what we're going to do is we're going to imagine, well, if the first one was a yes, then the second pick could be a yes, or it could be a no. But we're also going to draw a set of branches to show what could happen if the first one was a no. It could still be a yes, and it could still be a no. So it's looking pretty similar, but it will be important to have all of these branches in a minute. So let's work at the probabilities again. Well, because I replace the cards and I mix them back up, the probabilities are going to be the same, which means that it's still going to be 3/5 for yes, and it's still going to be 2/5 for no. It's still going to be 3/5 for yes, and it's still going to be 2/5 for no. And that there is a completed tree diagram. What we're going to do now is we're going to learn how to use it to figure out these things. And this is where your highlighters are going to come in handy. So, the probability of 2 yes cards. So I'm going to use my highlighter to highlight that sort of timeline, if you will, that series of events that has to happen. So I'm starting here, I have to get a yes, and then from there I have to get a yes again. And following that line is the only way of getting 2 yes cards. If I go any other route, I'm hitting at least 1 no card. So that is for number 1, what can happen. Now, I don't just want to highlight how it can happen, I want to work out the probability. And to work out the probability, we multiply the probabilities on the line. Let me explain why. It's just like flipping a coin and rolling a dice. If there's a half chance of getting a head and a 6th chance of getting a 5, there's a half times a 6th, a 12th chance of getting a head and a 5. These are independent events. It means they don't affect each other. That's what independent events means. Because they were mixed back in, shuffled up, the first pick didn't affect the second pick. They're independent, which means we're allowed to do that. So for question 1, to work out the probability of 2 yes cards, I'm going to multiply these together. And you can use a calculator at this point if you want, but I know multiplying fractions, just multiply the top and multiply the bottom, and that's going to get me my answer, 9 out of 25, 9/25. So that's how to do the first one. Now the second one, we've got probability of 1 yes and 1 no. So I'm going to, again, using some different color highlighters, figure out how that could happen. So 1 yes and 1 no. So maybe it's that branch there. But there is another way of doing it. If I look at the branches, if I get no first and then yes, that also works. So I've got 2 other timelines, 2 other possible things that could happen. So probability of 1 yes and 1 no is both of those things. So the green one, that's 3/5 times 2/5 this time, because that says 2/5 on that line. And we've also got this timeline, 2/5 and 3/5. And you might be tempted just to put another time sign in the middle, but because they're 2 separate timelines, the green one and the orange one, we're not going to times them, we're going to add them. So you times across the branches, and if you've got multiple different timelines, you add them together. I'm going to use my calculator for this one. I'll see if I can be quicker than my calculator though, because it's going to be 12 over 25, isn't it? So let's just check that. 3/5 times 2/5 plus 2/5 times 3/5, and I reckon it's going to be 12 over 25. Okay, so let's recap what we did there. We took the worded scenario and we put it into a tree diagram. So the 2 different things that were happening, we were going to pick a card and then we're going to pick another card. So that's where I got first pick and second pick. They're my events. Then at the end of the branches, I've got outcomes. So the first pick could be a yes or a no. The second pick could be a yes or a no and a yes or no. And I got 2 sets of branches because there's 2 potential different timelines I could be on. and on the branches go the associated probabilities. To work out something, you just figure out, well, what path do I need to take? What timeline do I need to take? And you figure it out, and it's probably best if you highlight it, just to be clear what we're doing. And you multiply all the different probabilities along the path. And then, if you've got something which can happen more than one way, and there's two possible paths, then you work out each path by timesing, but you add the two paths together to get your final answer. So, some questions on this. It starts off easy enough with fill in the blanks. So it's got a tree diagram already partly filled in, and you've got to fill in some blanks and answer some questions. It's also got this worked example, sort of typed up all neat with sort of annotations, so the sorts of things I've been saying, sort of written down for you to see. And also I will be available in chat to help with anything you need help on. Okay, so have a go at the questions and ask if you're stuck.